Today we're going to look at subtracting fractions with like denominators, and of course like denominators just means the same denominator. The numerator being the top number, the denominator being the bottom. Your learning intention for today: I can subtract fractions with the same denominator using models, diagrams, and subtraction statements. Molly is participating in a marathon to raise money for charity. She has 2/3 of the way to go. After she completes another 1/3 of the marathon, how much will be left? So we can estimate our answer by looking at pattern blocks. She has 2/3 to go. If we take away one of these pattern blocks, we can see that there is only one left. Then we use estimation to figure out whether this is closer to 0, 1/2, or 1. When you compare it to the pattern blocks, you can see that this is closest to 1/2. So our answer is going to be somewhere around 1/2. We can also use the pattern blocks to help us calculate the answer. 2/3 minus 1/3 equals 1/3. Copy these notes into your math book, and I want you to answer 3 questions. First of all, how can pattern blocks, models like pattern blocks, help you to estimate the difference between 2 fractions? Second, how do they help you subtract, or how can they help you subtract 2 fractions? And third, what are the limitations of using models such as pattern blocks, but not necessarily limited to pattern blocks, in subtracting fractions? What problems are there with using models? Let's take a look at 5/6 minus 1/6. Using pattern blocks, we can lay out 5 of the triangle-shaped ones, because the triangle-shaped ones represent 1/6. And then we can take away one of those triangle-shaped blocks, which leaves us with 4 blocks. So 4 1/6 blocks, or 4/6. But this isn't the lowest term, so we need to take a look at our pattern blocks and see if we can replace those with other pattern blocks. And if you look, you can take the blue pattern blocks, which represent 1/3, and you can replace 4/6 with 2 of the 1/3 pattern blocks. So 4/6 equals 2/3. We can also subtract fractions using diagrams. So we have a slip of paper that we split up into 8 pieces, and we color in 7 of those 8 pieces because 8 is our denominator, which means that our whole is divided up into 8 pieces. We only have 7 of them to start with, and then we're going to take away 3 of them. Which will leave us with 4 pieces out of a total possibility of 8. Again, we want to go down to the lowest terms, and if we look at our picture here, where that line 4 is exactly half. So using our picture, we can see that 4/8 is the same as 1/2. Finally, we can also subtract fractions using subtraction statements. Instead of having 11/12 minus 7/12, our denominator is 12ths in both cases, so we can put 11 minus 7 on top. 11 minus 7 leaves us with 4/12. And this is where our divisibility rules come in handy again. When we look at 4 and 12, we're looking for factors of both 4 and 12. So the highest common factor of 4 and 12 is actually 4. So both of these numbers are divisible by 4. 4 divided by 4 equals 1. 12 divided by 4 equals 3. So our answer in lowest terms is 3. It's really important that you always put your answer in lowest terms. Take a moment, copy down. We've got models, we've got diagrams, and we have subtraction statements. All three of these are possible ways of subtracting fractions that have a common denominator. Take a moment and copy this information down. Now I want you to consider what would happen if you were given a question like 1 minus 1/9. 1 isn't in fractions. How would you figure out the answer to this? Take a moment, write the answer down, write the question and the answer down in your math journals, and then come back. Well, what we need to do is we need to figure out how many pieces make up this whole. And if we're dealing with ninths, and we want to have the same denominator, how many ninths are in one whole? 9 pieces make up the whole, then we need to have 9 of them. So then we can do 9 ninths minus 1/9. And you can solve it in the ways that we have discussed with models, diagrams, or subtraction statements. I'm going to choose to do it with a subtraction statement. 9 minus 1 over 9. 9 minus 1 equals 8 over 9. So 1 minus 1/9 equals 8/9. Here are the key ideas for lesson 6.3. When subtracting fractions using models or diagrams, you need to be dealing with pieces that actually represent the size of the fraction. So, for example, the green pattern blocks to represent 1/6, or the blue pattern blocks to represent 1/3. Or if you're using fraction strips, you need to divide your strips equally into the number of pieces that make up the fraction for a quarter. And then when you're taking away, you need to take away the pieces or the parts that represent that are the same size. So if you're taking away 1/6, you take away 1 green triangle pattern block. If you're taking away 2/6, you would take away 2 green triangle pattern blocks. To estimate difference, look at how the fractions compare to 0, to 1/2, and to 1. To subtract fractions of like denominators, you're only subtracting the numerators, which is the top number. The denominator stays the same. And you can use models, diagrams, or common factors, which we find using the divisibility rules, to help you write your answer in lowest terms. Please copy these ideas down and then do your communicate the ideas questions from your textbook.